Hello, future engineers, subscribers, viewers, and students. Here is another beautiful and challenge problem in calculus about work. I hope that through this sample problem videos, your knowledge in integral calculus, particularly on the topic on work, will be enhanced. So here is problem 30. Shown is a graph of a force in newtons that increases to its maximum value and then remains constant. Uh, It increases from 0 to its maximum value, then it remains constant. How much work is done by the force in moving an object a distance of A, 6 meters from 0 to 6 meters, B, 8 meters, then C, 5 meters between 3 and 8, so that's 5 meters. So for the solution, take note of the principle that work done by a force is equal to the area under the force versus displacement curve. So that's the most important thing. In this case, we're going to compute the area under the force versus the displacement curve. So if it is from 0 to 6, so it consists of a trapezoid, or it consists of a triangle plus this rectangle here. So it is 1/2 of 4 times 30 plus 2 times 30. So this 6 minus 4 is 2 meters by 30 newtons. So computing, it is 120 joules, 120 newton meter. For part B, a distance of 8 meters, so from 0 to 8. So it is area of triangle, another trapezoid, but I'll just break this into triangle and rectangle. For the triangle, 1/2 of 4 times 30. For the rectangle, 8 minus 4 or 4 times 30. So 1/2 of 4 times 30 plus quantity 8 minus 4 times 30, and that is equal to 180 joules. For part C, 5 meters, a distance of 5 meters between 3 and 8. So we have to compute the corresponding value when x is 3 meters. I'll call that F3. So by similar triangles, F3 as to 3 equals 30 as to 4. So F3 as to 3 equals 30 as to 4. So F3 is 22.5 newtons. So therefore, the area is area of this trapezoid. That's 1 meter. So 1/2 of quantity 1 plus F3, which is 22.5 plus 30, plus the area of this rectangle, which is 4 meters by 30. So 1/2 of 1 times 22.5 plus 30 plus this rectangle here 4 times 30. So work is equal to 146.25 joules. Then let's proceed to problem 30b. The table shows values of a force function f of x, where x is measured in meters, and f of x in newtons. Use letter A, the midpoint rule, to estimate the work done by the force in moving an object from x equals 4 to x equals 20 meters. Then letter B, by the average force method, we simply get the average, then times the displacement from 4 to 20, so that's 16. 20 minus 4, 16 meters. Then trapezoidal rule, remember trapezoidal rule, area by trapezoidal rule is constant distance d over 2, quantity h1, the first offset, plus 2 times sum of intermediate offsets plus hn, the last offset. That's the area by trapezoidal rule. And area by Simpson's 1/3 rule is d over 3, constant distance divided by 3, quantity first offset h1 plus 2 times summation of intermediate add offsets h3, h5, 87, and so on, plus 4 times summation of intermediate even offsets such as H2, H4, H6, and so on, then plus Hn. Then this rule, because I begin with H1, is applicable if the number of offsets is odd. If the number of offsets is even, then we treat the last part as area of trapezoid. So for this case, n is odd, so we can apply the Simpson's one-third rule immediately. So this is the first, second, third, fourth, fifth, sixth, seven, eight, nine. So there are 9 offsets, so therefore we can directly apply Simpson's one-third rule. Trapezoidal rule is always applicable. So first, midpoint rule. So midpoint between, these are the midpoints. Second, fourth, midpoint between 8 and 12, midpoint between 12 and 16 is this, and midpoint between 16 and 20 is this. So there are 4 midpoints. Then work is by principle area under the force versus displacement curve, or simply integral of f of x dx. So the important thing is it is geometrically interpreted as area under the force versus displacement curve. So this is equal to mean average or mean force for 4 datas, then times dx, which is delta x here. And delta x is 20 minus 4. So F4 means the average of these midpoints, 5.8, 8.8, 8.2, and 5.2. There are 4 midpoints, so divided by 4. So work is 5.8 plus 8.8 plus 8.2 plus 5.2. These are the 4 midpoints divided by 4 times delta x, which is 20 minus 4. So work is equal to 112 joules. By average force method, we simply get the average of these forces divided by 9, then times 16, 20 minus 4. So the average is quantity 5 plus 5.8 plus 7 plus 8.8 plus 9.6 plus 8.2 plus 6.7 plus 5.2 plus 4.1 divided by 9 times quantity 20 minus 4, and it is equal to 107.4 joules. Next, by the trapezoidal rule, it is d over 2, where d is the difference between two adjacent offsets, which is 2, divided by 2, quantity h1, which is 5, then fn, which is 4.1, plus 2 times quantity sum of these intermediate offsets. So work is equal to 2 over 2, quantity 5, plus 2 times quantity 5.8, plus 7, plus 8.8, plus 9.6, plus 8.2, plus 6.7, plus 5.2, close, then plus last offset 4.1. So using your calculator, it is 111.7 joules. Then finally, 30b point D, work is equal to D over 3 quantity H1 plus 2 times summation of H add. So beginning with H3, which is 7 plus 9.6 plus 6.7 close, plus 4 times summation of H even offsets 5.8, 8.8, 8.2, and 5.2, plus, then close, plus the last offset 4.1. So it is D over 3 quantity H1, 5, plus 2 times summation of H add. So this is H3, H5, and H7. 7, 9.6, and 6.7, plus 4 times summation of H even, 5.8 plus 8.8 plus 8.2 plus 5.2, then close, plus last offset 4.1. So using your calculator, it is equal to 111.8 joules, which is supposedly close to that of the trapezoidal rule. So that's it for this video.